Today we're going to be building an enemy class that's going to be an eventual obstacle for our player to interact with. Let's begin. We're going to use the same approach we used for the player character, and that's that we're going to create a C++ class and then use that as the backbone for our future blueprint object. So let's start with that C++ class now. Inside your C++ classes folder, you can go ahead and create a new C++ class that is going to extend the actor. The reason we're going with actor this time is we want it to be spawned and placed in the world, but we don't want to actually control this. This is an enemy. Going into next, we're going to name this, and I'm just going to name mine enemy for simplicity. Creating this and waiting, eventually, after a short amount of time, you'll get a new C++ class and a new header file. Let's start with that header file to set up our contract. Now, we're going to need a private section of this file so that we can set things that we don't want anyone else to touch. So I'm just going to create keyword private, and then this is where we're going to declare all of our variables. The first things we're going to make are a couple of U properties that are going to designate the actual components we're going to be using for this object. The first component we're going to need is a box component to act as our collision. We only really want to set up the default value, so I'm going to call this a defaults only, and I'm going to put this in the category components. Then remember to forward declare your box component and give it a variable name. Next, let's make something we're actually going to see in the world, and that is going to be a mesh. So again, we only want to edit the defaults. Our category is going to be components, and then forward declaring a static mesh component, we're going to call this variable base mesh. With our U properties out of the way, we need to think of a couple of things that we're going to need for our enemy. Our enemy is rather simplistic, and all it's going to be doing is moving from the right side of the screen to the left side of the screen. But that being said, the difficult thing I want to implement here is giving it a variable movement speed, where the longer the game is going on, the faster it's going to move. So we're going to need two different movement speed variables here. The first one is going to be a float that we're going to call our base speed, and I'm going to set this just to be -500.f because it's a float. And this is going to be the default speed. This is where all speed is going to originate from. The second variable we're going to make is a float called move speed. And I'm going to leave this uninitialized for now because we're going to need to work with this variable in our actual C++ file in order to give it something with a little more oomph. So that's all for the header file. Let's go into the C++ file now, and now let's start diving into all of this mess. The first thing we have to do is make sure we include all of the header files that we promised we would include in the previous one. Now, the static mesh component actually does come standard, but we are going to need to include something called components/box component for the box component that we were saying we were going to use here. And then making sure you tip it off with the .h so it knows it's an actual file. And I think that's all we need for now. Now we're going to go and we're going to work in our constructor. The constructor is what's called whenever the object is created, and it's going to set up all the default parameters, just like with our character before. So first, let's start with our box component. So looking at box comp, we want this to be equal to a new default subobject. So we're going to call create default subobject, and then we're going to put in these little triangles what we want to create, and that's going to be the uBox component. And then we're going to put inside of these parentheses what we want it to be called. And I'm going to call this our box collision. Tapping all that off, we've now created our box component. Now, since the box is going to be the root of all evil, we're going to take a variable that exists called our root component, and we're going to make that equal to our box component. That way the box is the root of all evil. Next, we're going to do the exact same thing we did with box comp, but for our base mesh. So I'm just going to copy this for simplicity, and then I'm going to change some variable names. So instead of this being box comp again, we need this to be base mesh. Instead of this being a uBox component, this needs to be the uStatic mesh component. And instead of calling this box collision, we're going to need to go ahead and call this our mesh. Just as a general note, if you ever have two variables that are named the exact same thing, you will get a fatal error. So if you are getting an error, it might be because you didn't change this. So now with our constructor finished, let's go into begin play and set up what we want to happen on world start. So when the world starts, we want to give some value to our variable called movement speed that we had created before. Now we have to think about this in terms of we want our movement speed to increase as the time inside of our game increases. We know that in future lectures, we'll be creating a system to spawn these creatures in. So what we want to do is we want to find a reference to what the timestamp is when we spawn this creature, and then use that as the basis for our movement speed. So we want our movement speed to be equal to our base speed, because that's what we want all speed to be derived from, plus we're going to get the world, and we're going to call a method off of that called getTime in seconds. And since this is going to give us a float value, we do want to give it a little extra oomph. And we're going to say multiply this by an additional 10 just to give it some extra fly power here. So now we're saying that our total movement speed is going to be equal to our base value plus how long we've been in the world times an arbitrary incrementer. Now, something that's important to note here is this is going to cause a positive value. If we go back to our header file real quick, you'll notice that I set our base movement speed to be negative. The reason for that is we're going to be flying from the right side of the screen to the left side of the screen. So this is actually in its current form going to slow our character down. So what we're going to do is just simply switch this to be base speed, subtract our time in the world times 10, so that we're continually moving negative, which will increase our movement speed because we're flying from right to left. Now with our movement speed set up, we can go ahead and set up our tick function where we're actually going to move. So let's go down here. And something that I like to do in this case is, since we're going to be working with our component directly, we're going to do a little bit of protection for ourselves here. And we're going to say if we have a root component and it's not illegal or anything crazy like that, then we're going to be able to do our actual movement. So let's build this out. The first thing we're going to need is an F vector, which basically just stores location data. And we're going to call this delta location, which signifies a change in location. To initialize this, I'm going to make it equal to the 0 vector, which basically means a 0 in each of its spots. Now in this case, we are only concerned about going in the Y direction because that's how our game is set up. If we take a look at this, we can see that if we are pulling our game object to the right here, we can see that it's changing the location of the Y of our location. So we want to adjust the Y value so that it's moving from right to left. So our delta location dot Y is going to be equal to our total movement speed times a value that we're going to call delta time. Delta time is passed in through the tick function, and it basically lets us stay constant no matter how strong a certain computer is. This makes this value and this movement frame separated. So this means that it'll happen at the same rate on every computer. And then finally, we're going to set our root component to be equal to a new world location, which is going to be our current location plus our change in location, or delta location. And this is how this cube is going to move across the world. So now that movement is set up in a basic form, we're going to go ahead and save both of these here. So save everything in our project, and then I'm going to go to the bottom right and live code to recompile. With the successful compile there, we're now going to go ahead and create our blueprint. So right click on the enemy C++ class and create a blueprint class derived from this. My enemy is a perfectly fine name for our purposes, and we're going to throw that in the content folder because we are very disorganized. Once this comes up, you're going to have a very sad little component that's just all alone here. And the first thing we're going to do is we're going to go into base mesh, and we're going to give him a friend. So we need to give this a static mesh, and what I'm going to do is I'm going to give it the cube shape because I am not an artist and I'm not that creative, and now we have a little cube here. Now to make our cube happy, we're going to make it so that this collision box happily encompasses our actual box. Now, what I'm going to do for this is I'm going to lower this to the floor, and then I'm going to go to my box collision, and I'm going to make this bigger by working with the box extent. So I'm going to start by extending this out until I can see it. And now that I can just barely see it, I'm satisfied there. I'll just check the other side. I can just see it on both sides. That's perfect. Now I'm going to do it in the other way. And same thing, just until I can just see it poking out here. That looks good there. And now we're going to do it in the final direction, which is the hardest one. And now I can go back to my mesh and just keep lowering it down until we've got a pretty good fit. That is, all intents and purposes, a pretty good fit. So now we've got the blueprint for our enemy set up. Let's compile and save this here. So let's drag our my enemy into the world and see what's going on. And we can see immediately that something weird is happening here. Our box component is able to move completely separately from our actual mesh. That's not what we want. We want these two to move in tandem. Well, that is actually a lesson that we need to deal with inside of our code. So let's open up our enemy C++ again. So we can see here that we assigned the root component to be equal to our box component, but we didn't actually attach our base mesh to anything. So technically everything's working the way we designed it. So if we want to fix this little mesh separate from root component thing, we're going to go and call a method off of base mesh that we call setup attachment. So we're going to set up this attachment so that wherever our root component goes, our base mesh is going to follow. So let's save this and recompile. And after a success, we're now going to see that, well, first of all, this one's already fine because I already fixed it, but let's go back into our content folder and drag a new enemy into the world. And you can see that this is still not working as expected. This is something that I've noticed with Unreal, especially in this version, is whenever you're making changes to the actual hierarchy of your components or changing the components that exist on your object, you might have to recreate the blueprint class from scratch, and that's definitely something that's taking place here. It's annoying and I don't understand why it happens, but let's delete this blueprint class and force delete it out of everything. And then let's go back into our C++ folder to create a new version of this blueprint, which we're going to put into content. And then we got to do those same things that we did before once again. So let's just do that quickly here. So with that recreated, let's compile and save our new enemy, and then let's drag that into the world. And now you can see that the mesh and the collision are actually going to stick together and be an actual team here. So let's move this into place so that we can actually see what's going on. So now when I hit play, we can see that it is moving our character around, but we can see it's doing exactly what we want it to, and that's move from the right to the left and then hit our player. Now, if we just did this and kept spawning in our enemies completely and utterly forever, we're eventually going to overload memory because that's going to be a lot of enemies. So let's see when we should despawn these enemies. If I drag my enemy all the way to the right-hand side here, we can see that it is going off the screen, or at least off of this runway, at position 1390 in the negative. So if we ever see this move past, say, negative 1500, we'd know it would be really safe to just chuck it up and delete it. So let's go and implement that in code now. If we go back to our tick function here, we are now going to add an if statement inside of this so that we have something to track our movement. What we're going to do is we're going to say if we notice that our root component has a current location on the Y side that is less than negative 1500, then we are going to destroy this object. So let's save that and recompile. And let's drag our cube over to here. Let's drag it even further maybe. And let's just get this player out of the way so that it doesn't do anything crazy to us. And now I'm going to go and I'm going to hit play, and then I'm going to pop out. And now we're going to watch this cube move all the way to the left and then delete. That's exactly what we want. That's perfect. Now, the last thing I want to illustrate in this tutorial is how we're able to be so confident that our cube is going to increase in speed as we're spawning it later and later into the game. So let's go into code so I can set up this scenario. To illustrate my point, I'm going to add 2 UE logs. I'm going to put one UE log inside of our constructor, and I'm going to put a second log inside of our begin play. I'm going to save and compile this. And now with my output log open, I'm going to hit play. Now on this in particular, it's a little messy to see because everything is being constructed at the beginning. But if I scroll up top, we can see here that we do construct first, and then later we have begin play. What's interesting is this happens even if we are spawning in one of these enemies outside of the initial construction of the game. So our order of operations, so to speak, is always going to be constructor and then begin play, even if we're not necessarily beginning the play. It's the begin play of the certain object. So a common mistake that I made, and that I'm sure other people are making as well, is they're putting the initialization of their movement speed inside of the constructor, but then that gets overridden if you're doing anything different to it inside of begin play. So that's just a little bit of extra information for you there. And that's all for creating our enemy. In the next tutorial, I'm going to be going through and showing you how to create and spawn in these enemies using the game mode. So stay tuned for that. Have a fantastic day, and I'll see you next time.